4-6 Special Systems. Okay, just as a reminder, whenever you are solving a system by graphing, you would start at the positive 4, so I'm just going to graph this line. There's an imaginary 1 for the slope, so that means it's going up 1 and over 1, so that line has been graphed for you. The other equation starts at the negative 1, so that one's right down here. It's got a negative slope, so that means it's going down 3 units, so negative 3, and then over to the right 2. So I've got those two lines graphed on this picture, and the solution is where the two lines intersect or cross, so right there. So in order to write that ordered pair, I start at the origin, I went 1, 2 to the left, so that's negative 2, and then up 1, 2, positive 2. So solution to a system is the ordered pair where they cross. Let's go ahead and look at example number 2. This one starts at the negative 4. It's got an imaginary 1 for the slope, which means that it's going up 1 and over 1. So anytime that there's not a number on the bottom, like it's not a fraction, that means you're just going to move over to the right 1. So I plot all my points, and I'm going to go ahead and connect my dots. Then I need to graph the other equation. This one starts at positive 3. It's got a slope of that imaginary 1, so it's going up 1 and over 1 as well. I'm going to make sure that I go all the way through the picture. All right. So as far as the solution to this thing goes, a solution to a system is where the two lines cross. But these two lines are never going to cross because they're parallel. Now the reason that I know for sure that they are parallel is because they have the exact same slope. So they might be starting off at different points, but they're both increasing by up 1 and over 1, so they are never going to cross. So over here I want you to put that these lines have the same slope, which means they will never cross because they are parallel. Now as far as what the answer is to this problem, if these two lines are never going to cross each other and the answer is where they cross, well, this one has no answer, so we're going to put no solution. Now the other strange case is example number 3. I'm going to start at the positive 2 right here. I put my point. The 3 is the slope, so that means I'm going up 3, and since it's not a fraction, I go over 1. And I've just got to make sure I go in both directions. Once you've got your points, go ahead and connect your dots with a line all the way through. Now, as far as the other equation goes, this one is not in the y equals format, so what we need to do is solve this guy for y first, because we can't graph it until we have the y alone. So that's going to make that positive 3x the friend. That means I need to subtract it from each side. Now that's going to cancel and leave me with negative y equals. On this side, you want to put the x term first, so negative 3x, then the minus 2. Now the y is not completely by itself because that means negative 1y. So I'm going to divide everything in this problem by negative 1, which means I've got y is equal to positive 3x plus 2. Now if I graphed this one, I start at 2 and I'm going up 3 and over 1. But that's exactly what we just did because this is the exact same as the other equation. So that's what I want you to put right here. Now since these two lines are the exact same, that's like I have one line completely overlapping the other line. So there's two lines that are just mixed together right there. That means that every single point on that line is something that they have in common because they're just together like that. So for this one, we have infinite solutions. Okay. So just to recap that for you, whenever you are solving systems, you could have 3 possible answers. If your lines actually cross, your solution is just the point where they cross. If they're parallel, they're never going to cross. You have no solution. But if it actually is the same line completely just overlapping itself, you have infinite solutions. And that's how this looks when you graph, but now we need to talk about what this looks like when you are doing substitution or elimination. Now the first thing I want to talk about is comparing which step or which method you're going to use. For elimination, the x's, the y's, the equal signs, and the numbers, they're all lined up. But for substitution, everything's all jumbled up. I've got y and x and y, numbers, equal signs are like all over the place. That's how you know you're going to need to use substitution. And for substitution, you either need to look for an x equals or a y equals. And right here, that y is all by itself on the left side of that equal sign, so that's what I'm looking for. So if y is equal to all of that mess, that x minus 4, I'm going to plug that in place of y in the other equation, which will give me negative x plus x minus 4 is equal to 3. So I still have the negative x in the plus sign and the equals 3, but that has replaced my y value. Once you plug this in, you just need to do distribution and combining like terms. The negative x is not touching the parentheses, so it moves down. There is a plus sign in front of the parentheses, which means positive 1, so I can multiply. Positive 1 times x is positive 1x, and positive 1 times negative 4 is negative 4, and I bring down the rest of the problem. So after I distribute, now I'm going to combine like terms. Now remember, when you're combining like terms, you're adding the numbers in front. So this one's an imaginary negative 1, that one's an imaginary positive 1, and if I add that, I've got 0. So the x's have been completely canceled out of my problem, and all I have remaining is the negative 4 equals 3. So if all of the letters go away in your problem and you just have numbers at the end, you can't do anything else. And this is going to be one of those special systems. Now, negative 4 is not the same thing as positive 3. Those are not equal to each other. So if that happens to you, your answer is no solution. Let's look at the next one, example number 5. Okay. So I've got y equals the 3x plus the 2. I'm going to take all that stuff and plug it in place of y in the other equation. So that's 3x minus the 3x plus 2 inside the parentheses equals negative 2. After you plug something in, the next thing that you want to do is to distribute. So the 3x moves down because it's not touching parentheses, but the negative sign is, so that means negative 1. Well, negative 1 times 3 is negative 3x, and negative 1 times 2 is negative 2. This equals negative 2. Now when I combine my like terms, I'm doing positive 3x and negative 3x. Now you can think of that as 3 plus negative 3 or 3 minus 3. Either way, it's 0 and my x's are completely eliminated from the problem. I just have numbers remaining, which means it's going to be one of those special systems. But this time, negative 2 actually does equal negative 2, so that is a true statement. This one is infinite solutions. Now the last case of substitution. I'm going to move this paper up. We've got y is equal to that x plus 4, so I'm going to take the x plus 4 and plug it in place of y in the other equation. I have the 3x, I still have the plus 2, but the y is going to turn into that set of parentheses. This equals negative 2. Once I've plugged this in, the next thing I'm going to do is distribute. 3x is not touching parentheses, so it moves down. 2 times x is positive 2x, and 2 times 4 is positive 8. This is equal to negative 2. For my next step, I'm going to combine some like terms. I've got 3x's plus 2x's, which gives me 5x's. Everything else, I'm just going to move down. Well, this problem is different than the last two because when we combine like terms, we still have a letter. Well, that means this is just like the problems that we did last week. I would finish solving for x, so I'm going to move the friend over. Negative 2 minus 8 is negative 10. One more step to finish getting the x by itself. I divide both sides by 5, and I've got x is equal to negative 2. Now I can go back to one of the original problems. I think I'm going to pick y is equal to x plus 4, but you can pick whichever one you want. And I know that my x value is negative 2 now. So y is equal to negative 2 plus 4, which means y is equal to 2. You just type that into the calculator or add it in your head. So for my final answer on this problem, I've got to make sure I put the x in the y value. My x was negative 2 and my y is positive 2. So let me recap that for you. When you are doing substitution, once you plug something in, you're going to distribute and combine like terms. If your letters go away completely when you combine like terms and you're just left with numbers, it's either going to be no solution or infinite solutions. If you end up with a statement that's not true, like 4 equals 9 or negative 7 equals 50, Those two numbers are not equal to each other, that's no solution. But if you get something that is true, like -2 equals -2, or 7 equals 7, or -50 equals -50, that's infinite solutions. Now let's look at the last case. This is what happens when we use the elimination method. Now, for the elimination method, you have to have x's, y's, equal signs, and constants all lined up. If I want to eliminate my x's, my smaller number is 2, so that's the one that I'm going to multiply by something. If this is positive 4x, we need the other one to be negative 4x, so I'm going to multiply it by -2. Because -2 times +2 is -4, and that's exactly what I needed. Now I've got to make sure I multiply all the way through. -2 times -3 is +6y, and -2 times 1 is -2. The other equation, I am not making any changes to it at all. I'm just rewriting this one underneath. Well, now I have the same number in opposite signs in front of my x's, and I can just add going straight down. -4x plus 4x is 0. 6y plus -6y is also 0. So if you don't have any letters anymore, that's going to be one of those strange systems, but we don't know which one yet. However, since these both canceled out, we do have to put a 0 on that side to hold the place. And when I add the other side, -2 plus 5 gives me +3. Those two numbers are not equal to each other, which means that this one is no solution. Number 8. If I choose to eliminate my x's, my smaller number is 3, so I'm going to multiply that equation by something. This one is +6x, so I need this one to be -6x, so I'm going to multiply it by -2. -2 times 3 gives me -6x. -2 times -y is +2y. And -2 times 2 all the way over there gives me -4. The other equation, I'm not making any changes to it. I'm just rewriting this one underneath. Now that I have a -6 and a +6x, I can add my two equations. Those two are going to cancel. 2y plus -2y is also 0. So since I don't have anything remaining over there, I have to actually put a 0. And -4 plus 4 is also 0. These two sides are equal to each other. Those numbers are equal. So this one is infinite solutions. Last one. If I choose to eliminate the x's, my smaller number is the 1x. This guy is 3x, so I need this one to be -3x. And since it was a 1 right now, I can just multiply it by -3. So that multiplies there. Double negatives, negative times negative gives me +3y. And -3 times -4 all the way on the other side is +12. The second equation we just rewrite underneath exactly like it looks. And now I can take these two equations and add them together, moving straight down. So -3 plus 3 is gone. 3y plus 2y is 5y. And 12 plus -2 is 10. After that, I need to finish by dividing both sides by 5, and I've got y is equal to 2. So I knew that this one was going to be different than the last two that we did, because when we added the equations together, we did not eliminate the x's and the y's. We still had a letter in our problem. Well, now that I've got the first equation, or the first letter, I'm going to pick one of the original equations. I think I'm going to take 3x plus 2y is equal to -2, but you pick which one you want. And I know my y value is 2, so I'm going to plug that in. Once you've plugged it in, you need to take care of that multiplication. And then it's just a two-step problem. So I'm going to start by subtracting the friend, -4 to each side. Well, -2 minus 4 is -6. One more step to finish getting the x by itself. I divide both sides by 3, and I've got x is equal to -2. So when I write my final answer, I've got an x and a y value that's -2, +2.